Okay, welcome back to chapter 13. So far, we've taken a look at the Econo model. We said with the Econo model, we assume that the two firms do not collude, but rather produce output simultaneously. Of course, we're looking at a case where oligopolies do not collude. The next model we examine, which I did talk about, is the Stackelberg model, or oligopoly, where a leader firm produces output first, and the other firm produces output based on what the first firm basically produced. Having one firm act as a leader happens if the firm tends to enter the market first. Okay, so in the Econo model, we said both firms make their output decisions at the same time or simultaneously. Okay, they produce basically at the same time, right? But suppose, however, that one of the firms called the leader firm, okay, so with the Stackelberg, there's always a leader. So that's something you need to think about. Okay, with the Stackelberg oligopoly, there's always a leader firm that actually produces first, right? So suppose that one of the firms called the leader can set its output before his rival, the follower, sets its output. How is our equilibrium going to look like? Okay, so a real good world example of Stackelberg oligopoly is probably looking at the computer industry or the computer software industry in the mid-90s, right? So a good example is Microsoft at the height of its dominance in the computer software market, okay? Important thing to know is that the leader realizes that once it sets its output, the other firm will always follow. Okay, so the leader will anticipate what the other firm will do in setting its output, and hence in a way manipulates the other firm. Okay, so with this Stackelberg oligopoly, using a graphical model is quite confusing, so I'll just skip the graphical model part or the graphs and just jump right into the algebra. I think the algebra is really simple. Again, if you're going through this with me and you have any questions, please don't hesitate to ask. Okay, so let's take a look at an example. So we're going to stick with our usual example of American Airlines and United Airlines. Okay, so suppose you actually operate in an oligopoly of American Airlines and United Airlines, who actually operate from Chicago to Los Angeles. Those are the two airlines that actually fly from Chicago to Los Angeles. Okay, now we try to find the Nash-Stackelberg equilibrium. So remember, we used to find the Nash-Econo equilibrium. Right now, looking at the Nash-Stackelberg equilibrium quantities and market price, assuming American Airlines was the leader. Okay, so now we're actually assuming that American Airlines is the leader, and United Airlines tends to be their follower, right? So in our Stackelberg, you always have a leader again, and you always tend to have a follower, okay? And these two are pretty much synonymous with the Stackelberg model, okay? So assume we have the same market demand function and is given by Q. So Q is the quantity, market quantity. So this is the market quantity. Okay. You're given a market demand function as Q equals 339 minus P, where P is price, okay, or market price, right? And we assume that the marginal cost facing both firms is $147. Okay, how do we find the Nash-Stackelberg equilibrium quantities? And market price. So that is what we're looking for. So we've been given the market demand function and we've been given the marginal cost. How do we basically find the Nash-Stackelberg equilibrium quantities and market price? Okay, so again, to actually understand how to actually find the solutions, you need to go through we're using steps, and I always learn through steps. For me, steps makes things way simple. So I will just use steps to try and illustrate the solution. So step number one, you're supposed to find the best response function facing the follower firm, which is United Airlines. Okay, so this is supposed to be United Airlines. Okay, so remember our follower firm is United Airlines. So sorry for that mistake, guys, but it's United Airlines. Okay. So that's a typo. So find the best response function facing the follower firm, which is United Airlines. Okay, so we know that our market demand function is given by Q equals 339 minus P. Okay, to actually find the best response function, we already did this in the last lecture. We need to find the residual demand function, okay, for United Airlines. Okay, so the residual demand function is basically the market demand function minus the demand function faces American Airlines. In other words, it's basically the demand which is left over for United Airlines after American Airlines has met part of the market demand. Okay, so in that sense, we have QU, which is quantity for United Airlines, right, should equal quantity, or the market quantity, minus quantity for American Airlines, and that is given by 339 minus P, which is basically our market demand function, minus the quantity produced by American Airlines. So then we have QU, which is basically quantity for United Airlines, equaling 339 minus QA minus P. Okay, so once we've been able to find that, we can easily find the inverse demand function from the residual demand function, and it's going to be given as P equals 339 minus QA minus QU. Okay, so from the inverse demand function, again, just go back to the other lecture and you understand this better if you're actually confused. Okay, so the inverse demand function, we can actually find our MR. Okay, so we can find the MR for United Airlines. And how are we going to do that? I'm just going to give you a sec to think about it. To find the MR for United Airlines, all we need to do is multiply the slope by 2, because remember the marginal revenue curve is twice as steep as the demand curve for any firm. Okay, the marginal revenue curve is twice as steep as the demand curve for any firm. So you just multiply the coefficient of QU by 2. So we have the marginal revenue for United Airlines. We have MR equals 239 minus QA minus 2Q. Okay, the next thing we need to do, okay, remember we're trying to find the best response function for United Airlines. We're still on step 1. The next thing we need to do is that United Airlines is always going to produce at a point where marginal revenue equals marginal cost. So we equate that equation to marginal cost. So we have our equation over here, which is basically our marginal revenue equation. We equate this to marginal cost. Solving for QU, okay, should give QU equals 96 minus half times QA. And guys, this is our best response function for United Airlines. Okay, United Airlines is always going to produce at a point where marginal revenue equals marginal cost. And how do we get that? First, we need to find its residual demand function, find the inverse demand function. From the inverse demand function, you should be able to find the marginal revenue function equated to the marginal cost function, and voila, you should be able to find the best response function for United Airlines. Okay, so that is the first step. So United Airlines is always going to do this, and American Airlines can actually anticipate United Airlines' move. Okay, because American Airlines knows that United Airlines is always going to produce at the point where its marginal revenue equals marginal cost. So the next step in trying to find our Nash-Stackelberg equilibrium is step 2. And in step 2, we determine the inverse residual demand function facing American Airlines, which happens to be the leader firm. Okay, so like I said earlier, American Airlines knows United Airlines will choose its output using its best response function. Okay, so for American Airlines, its residual demand function is the market demand minus the best response function for United Airlines. Okay, so I'm going to repeat this. For American Airlines, its residual demand function is the market demand function minus the best response function of United Airlines. Why is it minus the best response function of United Airlines? Because the best response function of United Airlines is the point where marginal revenue equals marginal cost for United Airlines, and United Airlines is always going to produce at that point to actually maximize profits. And American Airlines actually knows this. Okay, right. So we have American Airlines quantity, which is QA, equals QP, right? So this quantity, which is basically its residual demand function, equals QP, which is the market demand function, minus the best response function of United Airlines, because it knows United Airlines is always going to produce this amount, QU, which basically is the best response function. So in that sense, it's going to be 339 minus P, which is basically synonymous with our QP, which is our market demand function, minus the best response function we had for United Airlines, which is basically 96 minus half times QA. And simplifying it, you should get 243 minus P plus half QA. Right, from there we can solve for P and essentially derive the inverse residual demand function facing American Airlines. And that's going to be P equals 243 minus 1 over 2 times QA. The reason we always try and find the inverse residual demand function, or the inverse demand function, is for us to easily get our marginal revenue. Because once we find the inverse demand function, right, so the inverse demand function is always denoted by P equaling some equation. Once we've been able to find our inverse residual demand function, we can easily find our marginal revenue function. And again, the marginal revenue function is basically going to be twice the slope of the demand function. So we multiply this by 2. So we multiply the slope by 2. So the marginal revenue function for American Airlines is going to be 243 minus QA. All we did was multiply this by 2. Okay. Now we know that American Airlines is always going to produce at a point where MR equals MC. We know our MC is basically 147. So we have 243 minus QA should equal 147. And American Airlines is going to produce 96, or basically it's going to fly 96 passengers. Okay, so fly 96 passengers. So we basically solve the quantity that American Airlines is going to fly, the quantity or the number of passengers American Airlines is going to fly, which is basically 96. Okay, if you don't understand something, I recommend probably going back right from the beginning and trying to figure things out before you actually move on. Once we've been able to find the quantity for American Airlines, we can actually move on. So we use step 4. Okay, we know American Airlines' quantity, and we can use that to actually find United Airlines quantity. Because remember, United Airlines quantity, right, basically depends on American Airlines quantity. Okay, so United Airlines is basically reacting towards American Airlines. We know that for QU, which is the best response function for United Airlines, we have 96 minus half times QA. Okay, we know QA equals 96. That's what we found, right? So then QU equals 96 minus half times 96. Okay, and then QU should equal 48. Okay, so American Airlines is going to fly 96 passengers and United Airlines is going to fly 48 passengers in our Stackelberg oligopoly. Once we've done that, basically everything becomes easier from there, and we can just use step 5. And with step 5, we use both quantities to find the market quantity and the price. Okay, so the market quantity is the sum of what American Airlines decides to fly and what United Airlines decides to fly. Okay, so there's going to be 96 plus 48 equals 144. And using the market demand function, we can also find P. And just use the market demand function, we solve for P. And we have 399 minus Q. Okay, but we know Q is 144. So we just plug it in here. And we have 195. Okay, we have 195. So basically, that is how we solve for the Nash-Stackelberg oligopoly figures. So we've been able to find the market quantity, we've been able to find price, we've been able to find the respective quantities for the two companies. Before you go on or you move on, make sure you actually understand what is going on. I know the algebra seems a bit complex, but try and just work through it, okay? So guys, there's a shortcut to doing this, okay? Every time you have a Stackelberg oligopoly and a linear market demand function, so let's say the linear market demand function is given by P equals A minus BQ, and sometimes you'll not probably be given a linear market demand function or an inverse linear market demand function. You probably have Q in relation to, let's say, A plus P. Sorry, that should be Q in relation to A minus P, for example. Always solve for P to actually get the inverse linear demand function, and from there you can actually work it. Okay, so this formula only works when you have P, right, being your main variable of subject. Okay, so suppose you have a Stackelberg oligopoly and a linear market demand function when you're given P equals A minus BQ, where Q is the market quantity and the marginal cost is defined as some letter M. Okay, you can actually find a profit maximizing output for the leader as Q1 equals A minus M all divided by 2B, and the profit maximizing quantity for the follower as Q2, so that's quantity 2, equals A minus M all divided by 4B. Okay, so using this formula, you should be able to find that for the leader, and you should be able to find quantity for the follower as well. Okay, so let's do an example. So assume a Stackelberg oligopoly faces the market demand P equals 150 minus Q. The firm has a marginal cost of $60, right? And you've been asked to find the Nash-Stackelberg equilibrium when firm 1 moves first. Okay, so using this formula, we can basically find the quantity for firm 1. We can also find the quantity for firm 2. We can derive the price, and we can also derive the market quantity. Okay, so we're going to use our general solution or our general formula to basically find the Nash-Stackelberg equilibrium. So from our general solution, we know that A equals 150, B equals 1, and M equals 60. Okay, so our Q1, which belongs to firm 1, which is basically our leader, is going to be 150 minus 60. Okay, so it's A minus M divided by 2 times B, so that's 2 times 1, and we get 45, right? So we don't have to go through all that response function, inverse linear demand, MR equals MC steps. We can just use this formula to find a quantity, okay? And it's way quicker. For firm 2, which is basically the follower, we have Q2, and we have 150 minus 60 divided by 4 times 1. Okay, so for firm 2, we have 22.5. Given how much firm 1 is going to produce and how much firm 2 is going to produce, we can actually find our market quantity. So in that sense, it's going to be Q1 plus Q2, which we already have as 45. We have Q2 as 22.5, and a sum of those will actually give us 67.5. Okay, so the market quantity is going to be 67.5 in this example. What about the market price? Well, we already have P. Okay, so market price is given by P equals 150 minus Q, right? We know our Q is basically 67.5. Okay, so our market price is going to be $82.5. Again, just let me know if you have questions, send me an email, and I'll be more than happy to respond. Okay, the next thing we're going to do is a comparison of competitive Stackelberg, Conoy, and collusive equilibria. Okay, so you guys have seen a whole lot of market structures by now, so you should have an idea of how they stack up together and what are the benefits of each of them. Okay, right? So how would American and United behave if they decided to collude? Okay, so again, let's say they decide to form a cartel, right? We have a duopoly and they decide to form a cartel. How would they behave? Well, if they colluded or if they decide to form a cartel, they act as one big company, in other words, basically a monopoly, right? And what would they do? They'll actually maximize joint profits by producing the monopoly output, just as you saw with cartels. So that'll be 96 units and a monopoly price of $243 per passenger. Okay, so they'll fly only 96 people and charge each of them $243. Okay, so extensively studying different market structures in a way helps us decipher which of the market structure is best for a consumer. Okay, so there's a table in your textbook that actually shows you that. Okay, so let's just go through the table slowly. All right, so we're looking at a comparison of duopoly, right, competitive, Stackelberg, Corner, and collusion, which is basically a cartel. Okay, right, so if the duopoly airline was very competitive, okay, it will actually produce 192 units, okay, fly 192 people, charge a price of 147. There will be a consumer surplus. At this point, you don't need to know how we calculate the consumer surplus, but there will be a consumer surplus of $18.4 million, right? But profits to their producer will basically be zero, right? So then producers do not have an incentive to actually be in this market, right? Producers don't make anything, but companies will benefit. I mean, consumers will actually benefit a lot because prices will be relatively cheaper, okay? If it was a Stackelberg, output actually reduces. Okay, so a Stackelberg is where you have a leader firm and a follower firm. Price is relatively a bit more expensive, but not too bad, $195. Okay, consumer surplus of 10.4, and the firm or the producers can actually make some profit. In a Cono, where output is determined simultaneously, they'll fly only 128 passengers, but price is substantially higher. Consumer surplus is substantially lower compared to perfectly competitive firms, or if the market was perfectly competitive, but the producer will actually make a profit of $8.2 million. If they decide to collude and act as a monopoly, well, they'll fly only 96 passengers, charge really high prices. Again, that's the reason why collusion and monopolies tend to be illegal. There'll be only a consumer surplus of $4.6 million. The consumers don't benefit from this market structure at all, but producers will actually benefit a whole lot in terms of having a profit of $9.6 million. Okay, so from the producer's perspective, collusion is the best thing, or actually operating in a corner equilibrium is the best thing for them to do. But from the consumer's perspective, having perfectly competitive markets is generally the best thing to actually do, right, or to have. Again, if you have questions, don't hesitate to let me know, okay? The next thing we'll look at is the Bertrand oligopoly. So far we've examined how oligopolies set quantities to maximize their profits. However, what if oligopolies decide to set prices instead of quantities, allowing consumers to determine how much to buy? In the case where oligopolies set prices and consumers decide how much to buy, we have what we call the Bertrand equilibrium. Okay, so now we've studied the corner equilibrium, we studied the Stackelberg equilibrium, and now we're going to study the Bertrand equilibrium. Okay, so the Bertrand equilibrium is a Nash equilibrium in prices, where a set of prices such that no firm can obtain a higher profit by choosing a different price if the other firms continue to charge these prices. Okay, so that is the whole definition of a Bertrand equilibrium. Okay, one key thing or assumption that we need to hold is that the Bertrand equilibrium depends on whether firms are producing identical or differentiated products. Okay, so whether the firms are producing identical or differentiated products. Okay, so we look at the Bertrand equilibrium, right, for firms with identical products. So let's look at the best response curves for firms with identical products. Okay, so suppose that each of the two price-setting oligopolistic firms, suppose you have two firms, the oligopolies, right? So suppose that each of the two price-setting oligopolistic firms in the market produces an identical product and faces a constant marginal and average cost of $5 per unit. What is firm 1's best response if firm 2 sets a price of $10? Okay, so how is firm 1 going to set its price? Well, if firm 1 charges more than $10, for example, if it charges $11, what do you think is going to happen? Everybody will actually buy from firm 2 because remember they have identical products. So why should I buy from one firm which is charging the same product for $11 whilst I could actually buy from a different firm which is charging the same product for $10? Okay, so then everyone will just buy from firm 2. What about if firm 1 decides to charge exactly $10 also? Okay, well, if firm 1 charges $10, it will make a profit of $5 on each unit it sells. Okay, so that's going to be 10, right, minus 5, because it costs $5 to produce each unit. Okay, so then you make a profit of $5. Okay, so suppose the market demand is 200 units and both firms charge the same price. We expect profits in the market to be split equally. Okay, so it's going to be profits of $5, sorry, times 200 units. Okay, all divided by 2, and we should get $500. Okay, so that's going to be $500 for each firm. Okay, right, now suppose firm 1 charges $9.99. Okay, so let's say firm 1 decides to undercut firm 2 by charging $9.99. It's going to capture the whole market. Okay, so the whole market is basically going to be captured if firm 1 decides to do that. Okay, and how much profit is it going to make? It's going to make a profit. We have $9.99 minus 5, because it costs $5 each unit. Okay, so that's going to be $4.99. Okay, so this is going to be $4.99. Suppose they're selling 200 units in the market. $4.99 times 200. That is going to be $9.98, because it basically captures the whole market. So it's going to sell every single unit in the market. So it's going to make a profit of $998. Okay, and if firm 1 decides to set this price at $9.99, firm 2 is going to respond and set this price at $9.98, and firm 1 is going to respond and set this price at $9.97, and so forth. Okay, but what if firm 2 sets this price at $5? Okay, what if firm 1 decides to actually go over than $5? So this is firm 2. What if firm 1 decides to charge $6 or set this price at $6? Well, basically nobody will buy from firm 1. Okay, but what if firm 1 decides to undercut firm 2 and sell at $4.99? What do you think is going to happen? Well, firm 1 is actually going to make a loss, because its selling is good at $4.99, but it's actually producing at $5. So that is basically a loss. Okay, so that's basically going to be a loss of however that much is 0.01. Okay, so firm 1 is never going to set its price below $5. Okay, so in a way, the moral of the story is that if firm 2 charges its price, okay, at basically $5, right, at the point where you have the marginal cost and average cost being equal to the price, there's no way firm 1 is going to undercut firm 2. Okay, so long as the price is set at a point where MC equals AC, which equals price, or so long as the price is set equal to marginal cost and average cost, there's no way the other firm will actually undercut the other firm in terms of price, and it will just sell at the same price. Okay, so it's in firm 1's best interest to also sell at $5. Again, if you have questions, just let me know. Don't worry about the graphs too much. The graphs are a bit complicated. Just worry about the concept and the equations. Okay, right. The next thing we'll look at finally is going to be monopolistic competition. Okay, and we said monopolistic competitive firms are sort of an in-between between a monopoly and a perfectly competitive firm. Okay, so monopolistic competitive firms markets do not have barriers to entries, right? So firms can enter the market until no new firm can enter profitably. Also, they basically face a downward sloping residual demand curve. So they tend to charge prices above marginal cost, just like a monopoly, right? But unlike a monopoly, you have many firms that can basically enter the market. So in a way, a monopolistic competitive firm can actually make zero profits and make negative profits as well. Okay. So two conditions hold in a long run monopolistically competitive equilibrium. Again, we have our good old friend marginal revenue equaling marginal cost. Okay, and that is the point where firms will actually produce to maximize profits. And also in a monopolistically competitive market structure, price usually equals average cost in the long run. Hence, you basically make zero profits. Okay, so remember, profits equals price minus average cost. All times Q, right? If P equals AC, right, we basically get 0 times Q, and a monopoly is basically doesn't make any profit. Okay, right? So price equals average cost in the long run because firms enter until no further profitable entry is possible. Okay, right. So with a monopolistic competitive equilibrium, you can actually find is almost the same as with the monopoly. Okay. The monopolistically competitive firm is going to produce at a point where marginal revenue equals marginal cost. Okay, and it's going to set a price, right, relative to where marginal revenue equals marginal cost and relative to the point where it touches its residual demand curve. Okay, so this is price, and it's going to produce at a point where residual marginal revenue equals marginal cost curve. Okay, so that's almost similar to what we've seen. And with the monopolistically competitive firm, in the long run, price is going to equal the average cost, like over here, as you see. And then finally, we look at fixed cost and number of firms. Okay, so the number of firms in the monopolistically competitive equilibrium depends on the firm's costs. Okay, so generally, the larger each firm's fixed cost, so this is sort of a rule. Okay, so this is a rule. The larger each firm's fixed cost, the smaller the number of monopolistically competitive firms in the market equilibrium. Okay, so the larger a firm has fixed costs, the smaller the number of monopolistic competitive firms in the market equilibrium. Okay, I'll suggest that you read more on the textbook, Okay, and again, if you have any questions, don't hesitate to ask me. Right. So this will conclude our chapter 13, and next time we'll be looking at, I think, chapter 14, which basically is the interesting topic of game theory. Again, I miss you guys and stay safe. Remember to wash your hands, and all the best.